Okay, so here is a hall voltage problem. I have already looked up the copper charge density, carrier density, and the hall voltage formula. Okay, and I've also drawn the polarity of the hall voltage. So the current is flowing in this direction, and what the hall voltage is, you have a voltage in a perpendicular direction to the direction of the current and the magnetic field. Okay, so when a current flows in a material in the presence of a perpendicular magnetic field, you develop a hall voltage. Okay, and now let me show you how to get this polarity. Okay, so the current is in this direction. In copper, it's electrons that carry the current, so electrons are moving in that direction. And an electron moving in this direction, V cross B would be in that direction, but since the electron is a negative charge, it feels a force in this direction. So all the electrons collect here, and that end becomes positively charged, so you have a hall voltage in this direction. And that is what this is. This hall voltage is equal to the current times the magnetic field times this length divided by the charge carrier density and the charge of the carriers, which is the charge of the electrons, and A is the area, this area of cross section. All right, so what are the values of the value and polarity of the Hall potential in this copper strip? So we already have the polarity, now we just have to calculate the magnitude. Okay, so let's do that. So let's put in these values. Is I is 100 amps, B is 1.5 Tesla, L is 2 centimeters. Okay, N is the charge carrier density is per meter cube. The charge of the electron is that many coulombs, and the area is 2 times 2 is that's 4, and the centimeter gets a 10 minus 2 meters, this gets a 10 minus 3 meters, so that's 10 minus 5 meters squared. Okay, so that's the area of this phase. Okay, all right, let's take care of powers of 10. This gets killed by that, so 28 minus 19 is 9, and that's plus 9, and then minus 5, that's 4. And we'll bring that up, so 10 minus 4, so 10 minus 4 volts. This is, that's 2 times 1.5 is 3. 8.5 into 1.6 into 4. All right, so this is okay, so this works out to 5.5 into 10 minus 6 volts. Okay. So 5.5 microvolts. So the Hall voltage is fairly small. All right, that does all the problems. So we will move on to chapter 12.